Hello, then welcome back to the fourth session on Oracle Architecture Deep Dive. Let me share the screen. So we have been covering the definitions of the components within SGA. So this is what where we had started. There is a last slide we discussed this one as the definition process manager. So let's continue the definitions. Let me put it full screen. Okay, up next is listener registration. Yeah, LREG, the listener registration process registers information about the database instance and dispatcher processes with Oracle Net Listener. Yeah, we will be covering this listener with Oracle networking as well as when we discuss about creating sessions with user process and server process. And other than that, actually what will happen, because listener should be aware of what are the databases that it is working with. So that is what one of the things that LREG process will do. It will register the databases with the listener. So anyway, for the time being, just leave it like that. If you want, we can take a look at it. Okay, let's take a look at it. Let's go to, yeah, let's see. Let me check my LSN RCTL. Yeah, if I just say, yeah, services. Yeah, currently it is showing me the databases that this particular listener is registered with. Let me just check the status. Yeah, so this is the default listener for my 19C database. And at the moment, it is aware of these databases, ORCL 19C, there's a container database. And yeah, and this one, yes, I think only one database. This is XDB one. Yeah, so that means this listener is aware of this particular database. This database is registered with listener, and it is running on 1522, not in the default port. Default port is 1522. And now any connections which are coming to this database will be served by this particular listener, default listener, but it's not in the default port. So, I mean, when the listener register, I mean, when a database registered with the listener, now, if somebody want to log into that database, any incoming request will be handled by the listener. So, what listener will do, depending on the port, because when a user want to connect, there is a user process. In the user process, he will be given username, password, and the last thing is a connect string. In the connect string, we are giving the listener port. So now for this particular database, if the port is 1522 and if the database name means, let's say, ORCL 19C CDB, then this listener knows that particular request is for this particular listener. Then he is aware of this database. So what will happen, that user request will be diverted to this particular database, ORCL 19C CDB. So that is how it's going to work all together. But don't worry, we'll be discussing this one in more detail. Step by step, I'll be explaining how the sessions are established and how this listener interacts then and there to establish the server process. Right? So for the time being, just get the definitions only. The recovery process, automatical resource failures in distributed transactions. Yeah, so that is in distributed environment. And we have this MMNL, memory manageability monitoring process. The not memory, the manageability monitor process, MON, performs many tasks related to AWR. We know the AWR report, not only the report, automatic workflow repository. So mainly for tune related activities. So this is, I mean, AWR, the statistics required for AWR, and this process is responsible for updating those things, and it is supporting AWR. So that's what. And again, MMNL, that is monitor light, right? Manageability monitor light process. It is for ASH, active session history. These are all again about tuning related tools. We know we have ADDM, automatic diagnostic detective monitoring, and ASH, AWR, all are tuning related. And this is to get the, I mean, the session information, active session history. So ASH buffer, actually ASH buffer is an optional, not optional, another additional buffer within the shared pool. That's why it is not indicated here. So, but ASH buffer, it is located in shared pool, and it is for tracking the session activities. Yeah, so that is that, and MMNL and MMON. The other one is PGA, Program Global Area. Of course, now we know what is PGA. It's a private area, non-shared memory region that contain data and control information exclusive for use by server and background process. This is explained earlier as well. Then this is a component within the PGA. So if I go back to our diagram, you can see that, and you can see here, SQL Work Area, session memory, private SQL, these all are subcomponents, small caches within the PGA. So that's what explained here. As you can see, so that is what given here, the SQL Work Area. This is used by functions that order data such as order by, group by. Yeah, that is for sorting. In SQL queries, we have order by, group by, so that requires sorting. So this SQL Work Area, memory area will take care about those functionalities. So that is what. And let's go to the next one, and we have session memory. Again, this user session data storage area is allocated for session variables such as logon information and other information required for a database session. Yeah, that is also belongs to PGA, Program Global Area. And I think that also there, no, in our explanation. But just take a look at this one. Let's check session memory. Yeah, this one, no. Yes, this is there, session memory. So that is what, again, unique per user, not shared. Specific session variables belongs to a particular user when SQL commands are being executed. You need some specific information to be retained within memory. So those things are, some of those things are managed within that area, session memory. This one, right? User specific information, such as logon information. Yeah, those also there. Then we have private SQL area, another component within the PGA. This area holds information about past SQL. Yeah, I mean, earlier also I told you, any SQL statement, when I explained the library cache will hold the previously executed execution plans of previously executed SQL statement execution plan. Now, I mean, to generate the execution plan, the first step is parsing. Parsing means we'll understand again more detail later, but for the time being, parsing means we need to check whether that the column names are correct, user has privileges, and the values are correct, and those things. There are a lot of checks happens in the parse stage. So at the end of the parse only, if everything is okay, I mean, or even object names should be correct. And if object name is correct, column name is correct, then the user has privileges. Likewise, when everything is okay, what Oracle does, it creates an execution plan. So what is mentioned here, this area hold information about past SQL information. Past means the statement that are already generated, or I mean, all past execution plans are already generated. So that means previously executed SQL statement. So we have those information, not everything, but private for the user specific information will be stored in this private SQL area. So this area holds information about the past SQL statement and other session specific information. Other session specific. Okay, so that's what, again, it's a private one, not a common one, but it's in the library cache, that is SGA, it is common. Okay, but this is even execution plan will have user specific ones, so those things are here. Right, so then the other one is smart flash cache. This is platform specific optional memory area, extension of buffer cache for databases running in Solaris and Linux. In Windows, this is not available. It provides L2 cache. Yeah, it's an extension of RAM actually, because now we know SGA is built on random access, volatile memory. But if SGA is running out of space, with what Oracle gives another feature called DB Smart Flash Cache. Now this is, in Exadata boxes, we have separate flash memory, but if you don't have Exadata boxes, even in normal computers with SSD disks, we know SSD disks, those are parsed. So SSDs are fast, speed is high. So therefore, you can get the benefit of this DB smart flash cache. If RAM is not enough, what you can do, you can define this parameter and you can allocate some space, but you need to provide the location and all the which disk and the size and everything. So it will act as a L2 cache for HGA, which is in the RAM. So anyway, we'll learn it more detail later. Smart flash cache. Think this is a 12.12 CPG, not a new one, but the enhancements are done in 19C. That's true. Yeah, I think we are good there. Yeah, finally the definitions. Finally, we have done the definitions, I think. Yes, now we are coming to startup, the next phase of startup, mount. Right. Actually, what we have been explaining here, you can see if I go back to the previous slides, this is all definitions. Before the definitions, we just started step 1 of instant starting. Right? Step 1, instant started, which is not mounted, not open. So from this step only, we went into all these components, identification, and the definitions. Now it is time to go to the second step. Now we know about instant starting and we know what's happening behind. And now we have idea about the definition, but not in detail, only the definition. Now we are a little bit familiar about these terminologies, but that is not enough. But let's continue to the next, rest of the steps, because after instant starting, it will do mounting, then it will do opening. So we need to understand in detail what is happening on those steps as well. Let's continue that. Actually, prior to that, let me show you something. Let's go to our practical environment prior to coming to this. Let me go here. Yeah, we have. Okay, I am in listener. No, so let's exit from here. Let's get back to SQL Plus. Okay, if I just type show SGA, or I can just say select star from SGA. Both use the same information. Now, most of the things you understand now. You know what is fixed SGA. It is explained. Database buffers, you know. I think variable size. Variable size, I don't think we had it. So what is variable size? Actually, variable size means now we know SGA, there are memory management techniques, right? So we have manual memory management and we have automatic shared memory management, that is ASMM. And we have in 12C, they introduce AMM, automatic memory management. Those are two things. ASMM was there starting from Oracle 9.9, 10G continuous, 11G continuous. 12C, they introduced AMM, that is automatic memory management. That is because they included PGA also to be automatically managed with, memory max size parameter was introduced. Memory target and memory max size. With shared memory with ASMM, what they had done, HGA target and HGA max size. We will learn those in more detail later. But for the time being, this variable size is something to do with this automatic memory management, because the value shows here. Now you can see this variable size shows around, I think, 72 MB or something. Yeah. Actually, what contributes to this variable size? Normally, it is a total of Java pool, large pool, and shared pool. Likewise, Java pool, large pool, and shared pool. Altogether, mostly will be equal to variable size, the sizes of those parameters. But again, not 100% equal. We have other overheads. There are other overheads other than the shared pool, Java pool, large pool. There are other overheads which gives addition to this variable size, which contributes to the total size of the variable size. I can tell you just an example. Let's say if there are number of control files are higher, let's say there are 2 control files, we are increasing into 4. Then what's going to happen? Some particular size will be allocated for those additional control files in the variable size. This size will little increase because of number of control files will increase. Likewise, anyway, that is just to give an idea about variable size. These things are understood. Database buffer, cache, redo buffer, that is very clear. Database blocks and number of redo buffers, yeah, that is clear. Okay. Yes, I think we are fine there. Yes, this is also clear. Right, now we have a proper understanding about instance. Proper understanding means not how it works, but the definitions. Let me just type shutdown immediate. Yeah, shutdown immediate. Let it shut down. Then now this is where are we now? We understood the startup command in this way. Let it shut down complete. Yeah, and we just understood startup no mount command because startup no mount. We are here now. Startup no mount. Only the instance started. So that is where our slide was explaining. This one was explaining instant starter, step 1 of our process. So what is step 2 and 3? Step 2 and 3, which comes here, step 2 is going to be in our explanation. Now this is okay. We have startup command. We know this component now. Instance we know. Control file will be getting open. So that is what we mean by mounted. Step 2, database mounted. Okay. So with this, we will continue in next session. I think otherwise it's going to be a lengthy session. And we got to know the definitions. I will start the next session from this slide. All right. Thank you very much. Have a great time. Bye-bye.